Okay, now in tutorial question 4, we have now a slightly longer problem. Okay, so you are asked to sketch the following graphs: y equals to 2 times modulus of x plus 1 and y equals 3 minus x divided by 4 on the same diagram. Okay, we are supposed to use these graphs to solve the inequality as shown. Okay, so let's first sketch the graphs. Okay, so from here, label your graphs clearly first, as well as all your axial intercepts. Okay, so make it a habit to do this for any graph that you sketch. Alright, now we are required to solve this inequality here. Okay, so to actually use the graph to solve, okay, we will need to first manipulate so that we can actually see the equation appearing on each side of the inequality. Okay, so what we'll get is 2 multiplied by modulus of x plus 1 is greater than 3 minus x over 4. So in other words, we want to see the intervals of values of x for which the graph of y equals 2 times modulus of x plus 1 is above the graph of y equals 3 minus x over 4. Okay, so to do this, we will need to find the points of intersection. Okay, so I'll leave it to you to use the GC to find. You should get the values of 4 over 9 and minus 20 over 7. Alright, so do check the previous few videos, okay, to state your conclusion properly. So using the GC, okay, what is your conclusion about the points of intersection? Okay, so therefore x would have to be strictly smaller than negative 20 over 7, or x is greater than 4 over 9. Okay, so that will be the solution for the first part of our question. Okay, now for the second part of the question, okay, we are now further pose another inequality. Alright, so when you see this kind of inequalities, okay, where the variables have now been changed, okay, square root of x, okay, you should try to suspect that we will be able to use substitution, okay, to actually relate this inequality, the second one, okay, to the previous one. Okay, this will require some work on our part to manipulate the inequality. Okay, so let's see how we can do that. So what we have is 8 multiplied by the modulus of square root of x plus 1 minus, plus square root of x minus 12 is greater than 0. Okay, so now what we should try to do is to try and manipulate to a form that is similar to our first inequality. Okay, so what I'm going to do now is I'll divide both sides of the inequality by 4. Okay, because I have a 2 times modulus x plus 1, Okay, I'll try to get a 2 times modulus of square root of x plus 1 here. Okay, so I have 2 multiplied by square root of x plus 1, okay, plus square root of x over 4 minus 3 is greater than 0. Okay, so we actually can manipulate further to get this inequality. So you realize that inequality number 2 here, which I'm labeling now, okay, is actually very similar to inequality number 1 as shown here. Okay, and the main difference lies in the fact that the x is now replaced by square root x. So we can use a substitution, y equals to square root x. Okay, so we will get back the original inequality. But this time we'll get y instead of x. Alright, so we can use our solution in the first part to conclude that y has to be strictly smaller than 20 over 7 or y is greater than 4 over 9. Alright, so now we replace both sides by both the y's in both the inequalities by square root x. So you'll see that the first one will have to be rejected because square root x cannot be negative, and this will give us our final answer of x to be greater than 16 over 81. Okay, so from how we actually obtain this solution is we square both sides on square root x is greater than 4 over 9.